Okay. So I got all of part 1 done, but I haven't done part 2 yet.
Okay.
Okay.
Well, let's start on part 2. We'll see if we can figure this, if I can figure this out. All right. The graduate management admission test is used in the criteria in many, I haven't slept hardly at all. Masters of Business Administration programs. The scores on the GMAT in the past have a mean of 529. The BYU professor feels now that the score has improved within the last couple years.
Okay. So the null hypothesis would be equal to the mean being 529.
No, would be greater than?
Not the null hypothesis.
Okay. And the alternative hypothesis would be greater than.
Yes.
Suppose you got evidence that the null hypothesis should be rejected. However, in reality, the mean score of the students taking this exam is still 29. What is a type 1 or type 2 error committed? What's the type 1?
If I remember correctly, type 1 is when you say that it doesn't happen when it should.
So it would be type 1. That's what they have in the answer key.
Yeah.
Okay. If the analysis was done at a alternative 0.01 level, what is the probability of committing a type 1 error? So that's just moving the decimal over to 1%, right?
Yeah. I think it would be a low probability, but I'm not sure if we can really get that one with the exact number for the probability because we don't have anything like the standard deviation or anything.
Okay. In the answer key, it says it's about 1 in 100 or a 1% chance.
Okay.
D is if we wanted to decrease the probability of making a type 2 error, would we need to increase or decrease the level of significance? And they have increased the level of significance.
Yeah, because when that's the level of significance is equal to the type 1 error, and then the other one is the type 2. So if we have a 0.01% level or a 0.01 level for the significance, low significance, then the type 2 error would be 0.99.
Oh, okay. A study by National Association of Realtors reported in 2004 the second home sales accounted for more than a third of residential real estate transactions. According to the report, the average age of a person buying a second home was 47 years. Assuming the standard deviation is 5, a real estate agent wants to determine if the average age of those buying investment properties in his area is different than the national average. Okay. In the A, it says that the answer, the researcher collects data from the population of his second home buyers. It says that he randomly selects a sample from his own clients. His research question is the average age of people buying a second home investment property in my area different than the national average?
Mm-hmm.
So B would be collect the data, name at least one way the realtor could randomly select a sample.
You could use a computer program to do it. Have a computer program randomly select the sample, but I think it would kind of be a little bit biased because he's only using his clients.
Yeah, well, he wants to find out if his average the same as the national average.
Oh, okay.
So I would just tell him to use all 15 clients that he has up there and find out what the mean is or the mode.
Yeah. Yeah, that sounds about right.
Describe the data on a histogram. Okay, so that's just doing it on the on the computer. Computer's now the one thinking.
Mm-hmm.
Okay, so five, 2, 6. All right, so did you put them in?
Yeah, my computer's being a little slow, but I'm doing it right now. I'm finishing it right now. Getting everything.
Huh. What is the history gone different? I guess it's not really different. It just looks different than there. So why am I missing? We go analyze data, description, statistics, explore. Okay, so then I got the median. Can't remember how to get the Q1 and Q3. What is going on with me?
The Q1 and Q3.
Oh, there it goes. I can't, it's not printing out the actual numbers for the Q1 and Q3. What did I do wrong?
What Q1 and Q3?
On the answer key thing, it says, it gives the mean, standard deviation, variance, minimum, Q1, Q3, medium, maximum.
Well, it should be. Did you put the percentiles on there?
No.
That's where you can figure out what the other
Is that under analyze?
Are the ones they have on the answer key the minimum 27?
Yeah.
Then it's 30. And the mean is 20.
49.
They have 49 for the mean.
Oh, for the, no, I'm sorry.
The
The mean
median.
is 46.73.
Yeah, the median. I meant the median. I forgot to look at that one. The median is 49, and then 55, and then the maximum is 58.
The minimum is
I guess it's-
27 and the maximum is 58. Yeah.
Yeah.
But
So
what is
yeah,
the
just
Q1 and Q3?
It's on the percentiles list.
Where do you get to the percentiles?
You go to the Analyze button,
Okay.
Descriptive Statistics, Explore, and
Okay.
then on the right-hand side, there's a button that says Statistics. You press
Okay.
that, and then you check the box next to the percentiles.
I did. What?
Then you press OK and OK. And then in the output box, just under the main box, there's the percentiles.
Oh, their Q. Oh, no, it's the same. I see it.
The 25% and the
Thank you.
75%.
Yeah, there we go. Thanks.
Yep.
All right, so make inferences. Let's check requirements. Since there's only 15 data pieces, what do you need to check next? And they have us checking the QQ plots just to check for normalcy.
Well, let's see if it's normally distributed, but it doesn't look like it to me.
So what do you think?
It almost looks like it's normally distributed. There's just one that's kind of off.
Yeah, so there's like 4 that aren't really on the line.
Well, it doesn't necessarily have to be that they're on the line, but in that general sense, it doesn't make like a really hard curve.
Yeah, okay.
Hey, Kellen. That's what it looks like to me. From the histogram, it does not look like it's normally distributed. It looks like it's more to the right, but that one on the QQ plot, it looks like it's pretty close to normally distributed.
Yeah.
So the first thing you would need to check is that if it's normally distributed.
So we would say yes.
Uh-huh.
State the null and alternate hypotenuse.
So the null hypothesis would be that the mean is 47 years.
Okay.
And so the alternative hypothesis
Is everything but the mean, right?
is not equal to.
Oh, yeah. 47.
And we have our level of significance right there. So we need to find the z-score now. So
So it would be 47.
it would be whatever we got for the mean minus 47.
Okay, so 46.73. Standard deviation. Square root of 15.
Okay, I got negative 0.118.
Just a minute, I'm not finished. So what did you get? I got a negative 0.1185.
That's what I got.
But on the answer key, it has z equals 0.20910.
Really?
Yeah. I don't know if you could see that.
Just give me a second.
So I don't know what I did wrong.
How did they do it on the answer key?
They didn't show, they just gave the Z formula. Oh no, oh wait, there it goes. The Z formula, and then they can't, that's what they have. This is mine. If we go backwards. Know that this one is true. We know that 47 would be true. So X, why are we getting a different X?
Well, even with it being like that, the probability is still too low for it to be, for us to not accept the null hypothesis. Because the probability is greater than the level of significance. See, that's not what I got. Do they use a different standard deviation?
.827.
That's what I used.
That's what I used to.
But I got 0.118.
That's what I got. Oh, someone's at my door. Hold on a sec. I love UPS or Federal Express. Anyway, sorry about that.
It's all right.
All right. So, but even those numbers being different, we can still say it's too low to accept an null hypothesis. Right?
Yeah. Yeah.
The p-value, well, that's going to be different because our z numbers are different than
Then there's.
theirs.
But what did you get for your?
Tell me it came. I bought my daughter a necklace for graduation and it said it was like behind schedule.
Mm-hmm.
So hopefully this is it. It is. There we go. P-value is the level significance.
What did you get for it?
This doesn't look like. I'm sorry, my head is not in the game today. What a cheat. Okay, so with first, what did you get as the area?
What?
So with our numbers in the graph, oh, where did that graph go? I came up with the p-value of a 0.9061.
Yeah, that's what I got. And so it's greater than the level of significance. And so we would fail to reject the null hypothesis. And in layman's terms, we have insufficient evidence to reject the null hypothesis.
Okay.
Thank you. So with that, what the real estate agent should do is continue to talk.
Do what he's doing.
Yeah, talk to middle-aged people to buy a second home.
Yeah. All right. Do we dare go try on to the homework here?
Let's go for it.
All right. There we go.
Okay.
Start. A hypothesis test consists of two hypotheses.
Mm-hmm.
So the null hypothesis is the status quo, right?
Yes.
Which hypothesis involves equality?
That one would be the null hypothesis as well.
Okay. The p-value is the probability of obtaining a simple statistic at least as extreme as the one that is actually observed. Uses information. When computing the probability, which hypothesis do you assume to be true? And that would be the null hypothesis as well, right?
Yes.
Number 6, which of the following represents the alternate hypothesis of for a two-tailed test?
It would be the one that is the mean is not equal to 10.
Okay. Which of the following represents a left-tailed test?
I think it's the mean is greater than 10.
And so the right would be less than 10.
Yeah. I'm not 100% positive about those, but that's what I think it is.
The outcome of the hypothesis test is determined by carrying the p-value. Which relationship would result in failing to reject a null hypothesis? Possibly. Which relationship would result in failing to reject?
If it's failing to reject it, then the
Yeah.
p-value is greater than the level of significance.
Okay. Level significance is the A kind of looking thing, right?
Yeah, the alpha sign.
Yeah. Oh, and rejecting the null hypothesis. Was it just opposite?
Yep.
Less than? An insurance company is reviewing its current policy rate. So it'd be greater than, right?
Yeah. The null hypothesis, because they think it is actually higher,
Yeah.
or the greater or a bigger number than 1,500.
Then what would 12 be?
The null hypothesis is that it equals 1,500. That's what the set average is at the moment.
Okay. 40 claim calculates the mean. I would say yes to 13.
Uh-huh. And then 14.
Lot would be, well, this one always gets me confused.
It's the central limit theorem. The central limit theorem is the one that says that if the population mean was, or the population was normally distributed, or if there's a large number of in the sample, then it will be normally distributed.
Okay.
The law of large numbers is that the more numbers you have, the closer to the true mean you will get.
Okay. So the test statistic is Z.
Yes. It's the z-score.
The historical mean still.
Now I gotta calculate the z-score for this.
Yeah. So you have 144 minus 50, right?
Yeah, 144 minus 150 divided by
40 divided by 6. So 6166. So I have a negative 0.900000.
That's what I got. Negative 0.9. So the p-value is, the one I got is 0.368.
That's what I got, 0.368.
Yeah. Okay, so what would we do? What do you think we should do? Reject or fail to reject?
I would reject the hypothesis.
The null
Wrong?
hypothesis?
Yeah.
Yeah, that is wrong. You need to fail to reject it. The reason being is because the p-score, or the p-value, was greater than the level of significance.
Oh, which was 0.05.
Yeah. So that's one thing you always have to remember is if the p-value is bigger than the level of significance, then you're going to reject it. If it's smaller, that's when you, or when it's bigger, sorry, you fail to reject the null hypothesis. When it's smaller, that's when you reject it.
Okay. There are two types of errors that can be made when performing a hypothesis test, which involves rejecting the null hypothesis when the null hypothesis is true. I've got to read up on this.
I think it's type 1.
Okay.
I'm not 100% positive, but I think type 1 was that it talked about the rejecting the null hypothesis when it was actually true. Okay, a researcher decided that instead of using a level of significance of 0.05, he will use a level of significance of 0.01. Which of the following will be true? Do you remember that one?
No,
Okay.
my brain is not functioning well.
All right. Between the two types, type 1 and type 2, there's 100%. So if type 1 has a level of significance of 0.01, then type 2 error will have the level of significance of 0.99.
Okay.
So it's always vice versa between the two of them. So if you decrease the amount or the level of significance for type 1 error, then you will increase the probability of type 2 error.
So it's the probability of type 2 error will increase.
Yeah.
Okay.
And then for 21, the level of significance is the exact same as the probability of committing a type 1 error.
So it'd be 0.05.
Yep. That's if I understood everything correctly.
Oh, we got the 7 and 8 mixed up.
We got the 7 and 8 mixed up?
Yeah, and 16 and 17. I did wrong. Oh well. All right. Thank you for bearing with me today. It's just kind of been a crazy day. I will be much more prepared next week.
Okay, that's fine. don't know how we got 17 wrong. Or you said you got 16 wrong?
Yeah,
What did you put in?
0.900.
It was supposed to be a negative 0.900.
Oh, yeah, it
But
was.
it should be correct.
And then 17, I got 0.368.
That's what I got. Oh, I know why it's wrong.
Why?
Because it was only supposed to be one side. It wasn't supposed to be both.
How can you tell?
Because it's not a two-tailed thing. It's just a one side. So it would be 0.184.
Okay.
So that's why we got that one wrong.
All right, thank
Talk-
you.